Good. So 3 was beta 1 equals 0, and then h of a is beta 1 does not equal 0.
Okay.
4, it's the difference between the observed value y and the value predicted by the regression line.
Okay. And then you guys are at 5.
Yep.
Okay. 5 residual supports these linear regression.
This is that they look normally distributed, right?
Yeah.
I think so, yeah.
Okay.
Because all the other ones are not true at all.
Yeah. I just looked over them again and I'm like, I'm pretty sure what I said is right. Okay. Then 6 is they form a linear pattern, right?
No, actually.
What was it then? Because I didn't see the negative 40 thing.
It'd be, well, it's asking for just the first graph on the residuals, right? Is that right?
Yeah.
Okay. So a linear pattern
Oh, okay, yeah, no, it's just straight across.
is a straight line.
Yeah, and they're all over the place. Okay, so then, is it the negative 40 to 25?
That's what I was thinking. I mean, it's kind of a weird answer, but
Yeah, I didn't understand necessarily why it would say that, but
because there's one that's negative 38 and there's one that's like 24.5
yeah,
or something.
something like that. Okay.
So yeah, that's just because all the residuals are all over the place.
Yeah. Okay. So 7 is that they're fairly normal?
Yeah.
Okay. You keeping up, Haley?
Yeah, sorry. I'm trying to pull it up in SPSS because I didn't do them before. And so I'm just trying to run the graphs real fast.
Okay. If you want us to go back, just let us know.
Yeah,
Okay.
we can.
Okay. What did you say for 8?
I checked all of them.
Same here. Okay.
Okay.
I didn't see anything that didn't fit, so.
No, because I mean, with the x values and the observations being independent, we pretty much just automatically assume, it seems, because we
Okay,
can't
so
really measure it.
for 7, you guys put the residuals are fairly normal, right?
Yeah.
Okay. Okay, then I think I did my graph right. Okay. Sorry. I'm so sorry, guys.
No, no. We're going above and beyond by doing it beforehand.
Okay. For 9, did you get 12.725?
Yeah.
Okay. Then 10.708 to 14.742.
Mm-hmm.
Then reject the null because the p-value is less than alpha.
Mm-hmm.
Then there is sufficient evidence to conclude that the slope of the regression line is not 0.
Yeah.
Then body length.
Mm-hmm.
And since the confidence interval does not contain 0, there is sufficient evidence to conclude that beta 1 is not equal to 0.
Yeah.
Okay, good. I was not sure about that last one because of the wording is kind of different.
Yeah, I had to go back to chapter 12, I think it was. Lesson 12.
Can someone explain 14? This doesn't really make sense to me.
Yeah.
Maybe if I just reread it.
I don't remember.
Basically, like if the confidence interval contained 0, you could kind of conclude that the slope is 0-ish. So,
Okay.
at least that's kind of the way I understood it. Is that how
So just
you
as
got it?
long as it doesn't have 0, it can't be 0, which I guess makes sense-ish.
Yeah. I don't know how to explain this. This is why I'm not a teacher.
Yeah, me too.
1 sec. Yeah, all it says is what pretty much Lindsay said. It just says, note that this confidence interval contains 0, so it is plausible that there is no difference in the mean number of nights the children in the two groups participate in reading. So it's saying that there's that you fail to reject the null hypothesis
Okay.
if the confidence interval contains 0.
Okay. Okay, that actually makes sense.
I had to read that like 10 times myself, so.
Okay.
Okay. So, is there anything else that you had questions on, Haley? That we can help you with?
No, I think I just need to go back through and reread it. Because I read it while I was sitting in class today, but I was sitting in chemistry reading it, and so I really wasn't paying attention as much as I should have been. So I just need to reread it, and then I think it'll make more sense.
Gotcha. That's good.
Okay. Did you want to submit it?
Yes.
I already did, and we got one wrong. 8.
8 wrong?
Yeah, 8's wrong. Seeing as I didn't contribute a whole lot today, I think I can contribute to this.
Okay.
You suffer to create a schedule for the qualifying them. Would it be the X values are measured without error?
That's what I'm wondering.
Didn't they say something?
Well, it wasn't an actual measurement, it was categorical data
Yeah.
for the confidence interval.
But it could
Not
be.
the confidence interval, but the level of confidence.
But it could be more than categorical since it is a number.
Yeah.
Yeah, that's a good point.
But everything else I think is definitely on there.
Yeah.
I'm gonna submit. 'Cause I think that's right.
The residuals are normally distributed, yeah. There is a linear relationship. There's no megaphone shape. Are the observations independent?
I thought
I was
so.
just looking at that. The scores are dependent, or like the confidence ratings are dependent on the scores. So I think that might be it. Because I was just going through the, like looking at the data. And then they are based on gender too. I don't think they're independent.
Did it go through gender too?
Yeah. Well, it's the way the data was collected. So they had like the, how many was it? 50? I don't know, more than that. 64 females. And like, I don't know, 70 something guys.
I guess that makes sense.
And then they've all got their scores and they all have confidence ratings to go with each. So I think it's that. I think they are dependent.
Because I think the weird thing about this one, though, for this lesson, it talked about how the a change in y, like if you choose a y, the y interval, The it doesn't say anything about the x interval.
Okay.
If that makes sense.
Yeah.
That's what it's measuring for this lesson. Because if you have a certain, well, I guess I don't know if I'm making any sense. It might just be.
Okay, so
going in
here's
circles.
the 3 requirements. So all the requirements for that should have been met, right?
For
For the math efficiency, I can't remember what the data is called. Okay, so I pulled up the requirements, and it's that there's a linear relationship, that the error term is normally distributed, the variance of the error terms is constant for all the values of x, and x's are fixed and measured without error, and that the observations are independent.
Mm-hmm.
So does one of those not fit? Oh no, it's all... Huh. I don't know. The variance for the error is constant.
I think it would be the independence. But
Okay.
then again, it seems like the stuff for the crocodile stuff would be dependent as well. So I don't know. It's just kind of confusing how it would be all independent.
Yeah.
I guess I just don't understand exactly how that works.
Yeah. Hmm.
What are your thoughts, Lindsay?
I don't know. I feel like it has most of them. Maybe not the observations, and maybe not the X. I don't know. That's where I'm at.
Yeah, I don't know.
Hmm.
So what are you guys putting for that one?
I think I'm just gonna leave the last two.
I just don't know how you would. It just says you can't really measure it.
Yeah. Okay, so it for sure has a linear relationship. The residuals are normally distributed. The variance is constant for all the values of x. Do we know for sure that the variance of the error term is constant for all the values of x?
Yeah, it is. Just because of the graph, the residual plot, if there's no megaphone shape, then that assumption is good.
Okay, so then that one. The x values are measured without error.
I'm pretty sure that would be the one. because it says, in other words, the x's can be considered as known constants. Your confidence obviously changes depending on the situation.
Yeah.
Head length is going to stay the same until you grow, but that's a specific measurement. It's not your confidence. So
Okay.
and then going back to the observations are independent. It says knowing the value of one of the y's tells you nothing about any other points.
Okay.
So
it probably is just the values x are measured without error.
yeah, so if you know somebody got a 73 on the test, you don't know. Well, gosh dang it. It seems like it could be both ways. It's annoying.
I think I'm just gonna leave the x values. Oh.
Okay.
What's that? I'm gonna go ahead and submit it. It says it's still wrong.
With both of them?
No, I put the observations back on. Just the x values I left out is still wrong.
So it might be both.
Did you already submit?
No.
Try it. I don't know what else it would be.
Yep, it's that one.
It is.
Okay. I want to figure out. Well, actually, I think it makes sense now. Because if you think about the measurement of x is a confidence, how confident you are in the test, and that is obviously going to change.
Yeah, that's true.
And it's not going to be constant, is what the definition for the assumption is. So we can mark that one off. And then the observations are independent. They are dependent, just because I'm trying to explain why. Because it seems like on the crocodile one it would be dependent as well, but I'm pretty sure it would just be dependent.
No. I think I understand it.
I want to know for sure, though. You can ask Brother Richmond.
Mm-hmm.
I can ask him.
Okay. Sounds good.
But now we know to be more careful with those.
Yeah.
Yeah.
So lesson 23. Question for number 8, right?
Yeah.
Okay. But I'm gonna send him an email, and y'all can go if you want to.
Alright. So